All right, so we're going to use the definition of binomial series to find the Maclaurin series for the given function. So we have f of x equals 1 over 2 plus x quantity cubed in the first case, and in the second case we have radical 1 plus x cubed. I'm going to start with part A with the fraction rational function 1 over 2 plus x cubed. And I want to remind you what a binomial series is. So if you have a series of the form 1 plus x to the power of k, and if you want to write down a Taylor expansion at c equals 0, this is exactly the series you get at the end. And you can try this out by yourself. Just look at f of 0, f prime of 0, and the nth derivative of 0, and then you will see like this nice binomial form. Okay. So let's go back. We have 1 over 2 plus x quantity cubed. So 1 plus 1 over 2 plus x, right? 2 plus x quantity cubed. Okay. So we're gonna sort of like write this out, but I have to put this first in this form here. Okay. So what I'm going to do here is that I'm going to factor 2 out, because I need 1 plus version of that, 1 plus, okay? So let's factor 2 out here. This is 1 plus x over 2, and then this is still the inner side of the cubic power, okay? So this implies that this is 1 over 2 cubed, 1 plus x over 2, 1 plus x over 2, quantity cubed, I think. Okay, so that should be equal to 1 over 8 times 1 plus x over 2 quantity cubed. Okay, and then we have, remember, in this form here, we have 1 plus x to the power of k. So I have to write this as a reciprocal. So 1 over 8, 1 plus x over 2 to the power of negative 3. Okay? Think about the case like where x equals x over 2 and k equals 3. So replace x by x over 2, k by negative 3 in the form of the binomial series. So I can rewrite this as like 1 over 8. 1 over 8. The first term is always 1. The second term is like negative 3. Well, x is replaced by x over 2, so x over 2. And then plus negative 3, negative 4 divided by 2, x over 2 quantity squared. Okay? And then this goes like on and on and on, right? Negative 3, negative 4, negative 5. Let me just write down the next term so you will figure out exactly what the rest should be. X over 2 to the power of 3. Okay? This goes again on and on and on and on. So we should probably write this in a nicer form, in a very nicer form, because we want to go back to the power series representation in the summation notation. Okay, so you can also pause the video and think about it by yourself. So it's 1 over 8, 1 plus. I'm going to start the sum from 1, going all the way to infinity. I have, as you see, I have an alternation going on here because this product is positive, but this product is negative, right? And this product is already, I mean, there's no product here, but it's already negative. So plus 1 minus 3 plus that term minus that term. So this is a minus term, right? Negative 3, sorry, this is a plus term, right? So minus, let me just write that down again. Minus term, plus term, and then this has to be minus because of the product negative 3, negative 4, and negative 5 is minus. So we should have some alternation. That's what I'm trying to get to. There's supposed to be some alternation going on here, and I'm going to take care of that alternation by minus 1 to the power of n. and this is n plus 2 factorial, and then you have 2 to the n plus 1, and maybe n factorial as well, x to the power of n. Okay, so go ahead and check this, and so like convince yourself that this is representing exactly what we have here. Okay, all right. So this is more like 4 factorial, but there's like if you look at this term here, let me just clean this a little bit more. So I'm talking about this term here at the top, right? -3, -4. That's almost like 4 factorial, but there is no 1 times 2 part of that, okay? And then this is more like 2 times 1, so 2 missing over there. So this looks like n plus 2 factorial divided by 2 factorial, okay? And then same thing here. This is n plus 2 factorial for n equals 2, but also you have to divide, you have to sort of like get rid of the 2 and 1 part. So that's why this is sort of like a nicer representation of, you don't need to write this full form if you can't catch the pattern here. Even this long form is good enough. The expanded form is good enough to conclude that you have the nice power series representation of 1 over 2 plus x quantity cubed in terms of binomial series. Okay. All right, and there's also part B, and I'm gonna finish this video now, and then please go to my next video to watch what's going on with part B.